In this vlog, I'll go through the process of setting up KVM, the kernel virtual machine, to run virtual machines that can be used to run web services. The motivation for this post was the need to run backend web services for an Android development project on my desktop to allow me to develop across the entire stack. I usually use VirtualBox to run my VMs, but Android Studio uses KVM to emulate an Android device, and you cannot simultaneously run both VirtualBox and KVM on the same machine. They are both hypervisors, and as a consequence, they conflict with each other when run at the same time. The solution is to use KVM to run the backend machines as well. This allows me to use a single hypervisor to run both the Android device emulator as well as the virtual machines running backend services. One consequence of this motivation is that the instructions here are primarily meant for users of desktop or laptop installations of Ubuntu, Fedora, or CentOS. A more general tutorial for setting up and managing KVM on servers must await a future blog post. The first step is to install KVM. On Debian-based distributions like Ubuntu or Debian, you can use the apt command and install the QEMU KVM and libvirt packages. For Red Hat-based distributions, you can use yum or DNF to install the QEMU and libvirt packages. Note that there is a slight difference on the names of the packages between yum and apt, and you'll have to use the appropriate command depending on what distribution you have. One of the glaring weaknesses of KVM compared to other hypervisors, particularly VirtualBox, is the ease with which bridge networking can be set up. It's not hard, but the documentation on the internet is not particularly good, and I've seen a lot of different advice, some of which is included in the references section of the accompanying blog post. The key problem with bridge networking is that with KVM is that while it is relatively simple to create a virtual machine that has access to a LAN that the host is connected to, and vice versa, that is, hosts on the LAN can reach the virtual machine, it is not possible for the host and guest VM to communicate each other when using the Mac VTAP interface on the guest. The fix requires some fiddling around with networking on the host, but once you understand what needs to be done, it's fairly straightforward. This is the hack I used. I think it can be done in a much less hacky way, but working code always trumps elegant code. So let's get started. First, you need to find your networking details. So you can do that by issuing the IP route command from a console on your host, and it will produce output that looks similar to the output I've shown here. You need three pieces of information: the physical network interface, the IP address of the host, and the IP address of the gateway, and coincidentally the address of your network. So we will use these pieces of information to set up the bridging on the host. The first step in setting up bridging is to create a bridge. To do this, we use the IP command, and this time the IP command must be issued as root. And we will create a new virtual interface with the name Mac VLAN 0 that is bridged to the physical interface. And the command you can see is shown below. The name Mac VLAN essentially adheres to convention of naming interfaces in Linux, and we adhere to that convention here. So essentially with the IP link add command, you have now created a new Mac VLAN 0 interface that is bridged to the ENP2S0 interface, whose name we got from by looking at the IP root command earlier. The next step is to assign the host's IP address to the Mac VLAN interface, and you can do that with the IP address add command. Finally, we will bring up the Mac VLAN interface by issuing the IP set dev Mac VLAN 0 up command as shown below. And that's it, your Mac VLAN is up. After this, you need to set up routing. The first step in setting up routing is to flush your IP routes, and you on both interface, both the physical interface as well as the bridge interface. Then you make the bridge the primary interface by adding the route to the network, to the LAN, with a metric of 0. And this is important because then for all traffic destined for this network will be sent to the Mac VLAN interface. Finally, re-add the default route via the which was flushed out by the previous IP route command. And now you're all set up. One thing you need to take care of is that you issue these commands exactly as they're shown, because if you make a mistake, it is quite possible that you will break networking on your machine, and you will be unable to connect to the network. This is simply remedied by simply rebooting your Linux machine, and you will be fine. So no damage done. However, this is one of the reasons why these instructions are meant for desktops or laptops and not servers, because you can't issue these instructions over SSH for the fear of losing your network connection and therefore losing access to your machine. Next, we create the virtual machine using Work Manager. Work Manager is the GUI front end for QEMU KVM. The process is quite straightforward. Go to the File menu, create a new virtual machine using the New Virtual Machine option. Select Local Install Media because we'll be creating a new VM. For the ISO image, you can browse the local file system. And the UI is a little bit confusing here. Essentially, you need to click Browse Local in order to get the file dialog box. I've chosen a CentOS 8 ISO image that I've downloaded from the CentOS website. And I go to the next step. You need to tell KVM what OS and OS version you're using. It doesn't always guess it right automatically. I've just taken the default memory and disk space options just for demo purposes. You can change that on your own. One thing you must do though is use the Mac VTAP option that is connected to the host device, not the Mac VLAN bridge interface, and then give the machine a name. It guesses a name, but it's best if you choose a name for yourself. It then creates the virtual machine and then launches you into the installation dialog, OS dialog for the VM. This process is specific to the OS you're installing, and so we can speed up through that process and get to the end where the OS is installed and you are logged in and all set up with the OS. And that's it really. You have your OS ready, and you can start using the VM. Happy coding!